Okay, this is exercise 6.3, Q2. Again, I'm doing some even numbered problems since the homework is the odd numbered. Now, this one, we have to show that this sentence is a contradiction. Now, there's two ways to do that, all right? And I'll do both of them for number 2. The first way is to prove that the negation of this sentence is a tautology. Right? In other words, if we could show that this sentence is a tautology, then it proves that its negation is a contradiction. Right? So that's easy enough. If we want to prove this is a tautology, we derive it from no premises. It means we have to start with an assumption. Since it's a conditional, we'll want the consequent. Assume the antecedent, want the consequent. Oops. Okay, but this too is a conditional, so we assume T, we want S. Now we can just drop S down here by reiteration of 1. That gives us, if T, then S by conditional introduction to 3. So there was our assumption, there was our consequent, gives us the conditional, and that in turn gives us S, then T, then S by conditional introduction of 1 through 4. So we've proven then that S, then T, then S is a tautology, and so that's enough. It follows that the negation of S, then a contradiction. So that's one way to do it, is to show, we wanted to remember to show that not S conditional T then S was a contradiction. How do we do that? We derive the negation of that and show it's a tautology by deriving it from no premises. That in turn proves then that this is a contradiction, since the negation of a tautology is going to be a contradiction. Remember, tautology means always true. So if every value is true and you negate it, it's going to turn every value to false. And every value false means contradiction. Now there's another way you can do this as well. And the textbook talks about both ways. So let's call this 2A. 2B, the other one we can do is we can take the original negation, the original sentence on as a premise, and derive a contradiction from it. If we can derive a contradiction from this sentence, we prove that it is itself a contradiction. Okay. So this is just a premise, or sorry, an assumption we're using to see if we can derive a contradiction for proving a contradiction. You don't have to write that, I'm just writing it. Okay, so now we have this sentence. What do? Well, we can apply the negation, but we first have to do some material conditional steps inside the parentheses. So how do we do that? Well, we'll start with the very inside. S, then not T or S. So remember, when you do a material conditional, the left-hand part, if it doesn't have a negation, it gets one. The conditional turns into disjunction, and the right-hand part stays exactly the same. That's MC1. Now we can do the same thing with this conditional. We have negation, not S or not T or S. So again, ignore the negation outside. We're doing this conditional inside the brackets. So we change the S, since it didn't have a negation, it gets one. Change the conditional to disjunction, and the rest of it stayed exactly the same. MC2. Now we can do a De Morgan's. We can apply the negation across. So that'll give us not S and not T or S. De Morgan's of 3. Okay, so remember, De Morgan's distributes the negation across both disjuncts. So the first disjunct is not S, so that gets another one, not S. The disjunction turns into a conjunction, and then the second negation goes on this sentence. Okay, so now we can do the De Morgan's on this part. It'll give us not T and not S. So again, this part stays the same. We're just doing the De Morgan's here on the second conjunct. So the negation gets distributed across. So T has 1, so it gets another one. Disjunction turns into conjunction. S has 0, now it gets 1. Okay, so remember, we need to end up with a contradiction, much like with the negation rules. All right. So how do we do that? Well, we can get not T and not S on a line by itself by conjunction elimination of 5. Then we can get not S by itself, conjunction elimination of 6. And then we can get not S by conjunction elimination of 5. And there's our contradiction, right? Not S, not S. All right. So since we derived a contradiction, that proves the original sentence that we assumed was itself a contradiction. Okay, so 2 ways. First, take the negation off, derive that sentence from no premises to show its tautology. That proves then the negated sentence is a contradiction. Second method, just start with that sentence, apply the rules, derive a contradiction, and that shows the original sentence was a contradiction. Okay, let's try number 4. Okay, so here we have a conjunction, right, of 2 sentences, right? So there's a couple ways we could do this. We could do each of the sentences individually. So if this is a tautology, if this is a tautology, then the negation is going to be a contradiction, right? And if this is a tautology, the negation is going to be a contradiction. But I think what we're better off doing is assume this whole thing and see if we can derive a contradiction from it. So let's just put this sentence here. Clause 4a, number 1. And let's see if we can derive a contradiction. Okay, so first we'll do a De Morgan's on this left-hand conjunct. So that'll give us not A or not B and not A or B. So that's De Morgan's of 1. We can do the double negations, get A or not B and not B. So that's double negation of 2. Now notice you have to do these one at a time. Double negation of 3. Now we can do the De Morgans on the second conjunct. That'll give us not A and not B. Remember, De Morgans, you distribute the negation across both sentences and you change the disjunction to a conjunction. Okay, so now we got a conjunction, so we can get each of these on a line by itself. Conjunction elimination of 5. Not A and not B. Conjunction elimination of 5. Now we can get not A. Conjunction elimination of 7. Not B. Conjunction elimination of 7. And now we can do a disjunction elimination either way. So we'll use not A and to get B. So that's disjunction elimination. 6 is our disjunction. 8 is the negation of A, so that gives us B as a result. So 6, 8. Right, so there's our contradiction. Not B and B, so that proves that the original sentence was a contradiction. Okay, so running out of time. Let's see, 6. I should actually call this one 4B since I used the method from B above here. So 6, again, you can use two methods. You can derive the negation, or derive this sentence without a negation using conditional introduction to prove it's a tautology, right? Or you can just assume this sentence and prove or derive a contradiction from it. I'll try that one, I guess. Okay, so first we'll do the De Morgans. We got the negation of a disjunction, so that gives us not D conditional D and not D conditional E. That's De Morgans of 1. So again, we had not this or this, so the negation gets distributed across both disjuncts and the disjunction changes to a conjunction. So now we'll do two material conditional steps, not D or D and not D. Okay, again we have to do these separately. So not D or D. So now I'll do this one, not D or E. So remember, material conditional, the first part gets a negation since it doesn't have one. Conditional changes to a disjunction. Second part stays the same. Same here. The first part, since it doesn't have a negation, gets one. Conditional changes to a disjunction. Second part stays the same. Okay, so now we can do another De Morgans. We'll get not D and not D, and I'm going to skip some steps here because I'm running out of time. Not D and not E. So that's 2 De Morgans from 4. I'll put a plus on there to show that I did 2 steps in one. Similarly, we can do 2 double negation steps from 5. Okay, so now the question is, where's our contradiction? So now we can do a bunch of conjunction eliminations, and we can get D on one line, and we can get not D on another line, and that'll show that the original sentence then was a contradiction. About out of time though, but all you have to do is from here on is conjunction elimination until you get D and then not D.